Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Concept: terminal alkynes are weakly acidic, pKa 25. A strong base like LiNH2, pKa of conjugate acid 38, deprotonates the terminal alkyne to form a lithium acetylide, Carbanian organolithium salt. Step 2. Formation of a CH3, CH2, CH2, CCH plus LiNH to CH3, CH2, CH2, CCl plus NH3. So compound A is the lithium acetylide CH3, CH2, 2CCl. Step 3. Reaction with CH3 to SO4 dimethyl sulfate, CH3 to SO4 is a methylating agent. It donates a methyl group, CH3, to the nucleophilic acetylide carbon. The acetylide anion attacks the electrophilic methyl group of dimethyl sulfate via an SN2 reaction. Step 4. Formation of BCH3, CH2, 2CCl plus, CH3, to SO4 CH3, CH2, 2CC, CH3 plus LiOSO3 CH3. Compound B is therefore CH3, CH2, 2CC, CH3, which is 2-heptine, pent, 2-ene extended, hex, 2-ene. Step 5. Why other options fail? Option A. SO3H group cannot come from CH3 to SO4 methylation. This would require sulfonation chemistry. Option C. CH2OS is equal to O is equal to O. H is a sulfonate ester acid fragment, not the product of simple C alkylation by dimethyl sulfate on an acetylide. Option D. CH3, CH2, CC, CH2 is an incomplete structure, carbene-carbanian, and does not represent a stable neutral molecule. Also, the carbon count and connectivity are wrong. Option B correctly represents the product of methylation of the terminal acetylide carbon, giving an internal alkyne with a methyl group added at the terminal carbon. Therefore, the correct answer is B. Therefore, the correct answer is option B.